extended Q&A. So, hello everybody. I'll start then. My name is Will Stephenson. I'm a developer at openSUSE. I'm a KDE developer, and I'm an openSUSE booster, which means that I get to come to events like this on the other side of the world and talk to you about software, which is great. So, today the topic of my talk is the openSUSE build service and how we're going to be able to spread KDE with that and make the world a better place. So, start with our key messages, the things that you should know if you don't take anything else away. Number one, the build service is for everybody. It is, although it's the instance that you see at build.opensuse.org is called the openSUSE build service. It builds distributions, packages for any distribution that we support, which at the moment is RPM and Deb-based distributions. And everyone is welcome to turn up and use that instance for their needs to package things. Second, the build service always has been and always will be free software in all of its components. It's made up of Perl, Python, and Ruby components because we just want to make sure all our bases are covered. And all of those are released under the GPL or related free licenses. It's freely downloadable. It's packaged for several distributions already. Its source code is in Gitorious. You're all welcome to download and do with it what you want. And indeed, although in the openSUSE instance, we have a policy that we only allow free software. Many companies are already downloading it themselves and using it to build their proprietary software and release it themselves. So it's really a free software tool which is generally useful. And three, this is the main point of this talk. The build service makes it easy to package and then distribute your KDE apps, your wallpapers, anything that you might want to run on, you want to see as a part of KDE, you might run as part of your KDE distribution. So, let's look at a few details. So, you might think, well, we have build farms, other distributions have build farms. It's a good way of turning the machine on your desk into being a useful workstation and getting all that noisy, loud, boring compilation happening somewhere else. Well, it does do that, but it's a lot more than just that, a build farm. It's a source code repository. It's actually a tarball repository. You can upload different versions of your software. You can have it then built on different architectures with different compilers, with 32-bit, 64-bit, or even on PPC or ARM architectures. You can build not just single packages, but you can build entire distributions. In fact, that's the latest openSUSE has been completely built in the build service. It's almost a self-bootstrapping system. It's got dependency management. So if you have a KDE libs package and a KDE base package and a KDE pim package, an AMROC package, if you change the libs package, everything above that will automatically rebuild. So this is how much processing power we're doing. When we're in the hot phase of building openSUSE, the entire distribution is being consistently rebuilt maybe every 24 hours, somewhat less. It depends how much trouble OpenOffice causes. You really wouldn't believe how much trouble OpenOffice can cause. And then once you take one of those, a large repository, like, for example, we have one for KDE, which is called KDE KD4 Factory Desktop. And that has the version of KDE which we're putting on the latest openSUSE. That has all that dependency management happening inside that. But then you can also layer repositories. So if we have a user who wants to replace Amarok, maybe he doesn't like Amarok 2.2 and he really wants to stay with 2.1. Hypothetical scenario, but it got your attention. That user can then define a project which says bases not on the boring 11.2, but on KDE KD4 Factory Desktop, which has a much newer KDE 4.4 beta in it. And his AMROC will be built always according to those KDE libs. If they change, his code gets rebuilt, and you don't have a package which is then distributed at a later time, which is then binary incompatible to what's on the base distribution. And it's secure. Of course, when you're uploading source code, the user always has to take responsibility for what they install. But it's a highly secure, separated system. There is a signing system in place, which is, I can't, without going into a lot of details, produces signed packages without any risk of the key material or anything becoming compromised. So users, if they trust if their repository, and each repository has its own key, so that you can say, well, I trust the repository coming from the KDE team at openSUSE, I will add their extra software, then you know that it's going to be coming from them. Oh, interesting.
Can you form teams as well as just individuals?
Say again?
You saying you could form teams as well as just individuals?
Yeah, there is also a user model in there. So you have maintainers in a package who form a group. You can have groups there, and they have certain amounts of rights that within that package and within that project, within sub-projects. I'll come on to the user side slightly later on. And as I said, it's not just a machine that compiles your code and gives you something back. It gives you your binary packages. It gives you binary packages for different distributions. It will give you your source packages. It will give you it doesn't just put those in a directory. It doesn't just dump those in an FTP site. Those create distribution repositories, which your apt client can then be pointed at, your yum on openSUSE zipper, the DRAC RPM thing for Mandrake. You can register these repositories which are coming out of the build service, and all your users can then download the software from there, even though it's not openSUSE software. And that, for our instance, that's connected to a highly scalable mirror infrastructure, so that you know that, for example, KDevelop, they're using the build service themselves. Their latest versions of KDevelop are always available worldwide in a network of mirrors. And we're even building entire distribution images as well as the metadata that is in the build service allows you to say, well, openSUSE 11.2, give me an ISO, and out it comes. Clients, well, how are we going to access this? Well, I'll start by showing you the web client. We have a fairly fully featured web client. I'll just go back to my home page there. So when you first sign up on the build service, you will get something to wait for because we're a long way away. There we go. You'll get a view like this, and I will just try and shrink it down so it fits nicely. So you see here we have some packages. I have a lot of sub-projects of different things that I use. Here we have a view of all the repositories that I have registered for my home project. So I'm building for 2 different older versions of openSUSE and the current version. I've got a list of maintainers. In this one, it's just me. And you can do things like adding a package here. You give it some metadata. It creates a package which you can then add sources to, add spec files, add, and then when you've done that, when you've added the sources and your spec files and any patches that you need, then you're going to, somewhat later, you're going to get a package come out of it. And I can say, I'll add a repository. So maybe I want to start building my software for Fedora 12. Click on Fedora 12. In the build service, there's a complete set of Fedora RPMs. So if my spec files are appropriately configured, they will then build the software versus Fedora 12. Any online updates, they're also synced in with that set of RPMs. And you have very fine-grained control of what happens here. So these little flags here, these little green things here, build and publish. I can then control, if I'm doing a KDE 4.4 Beta 2 RC1 release, I can prepare all the software on here. Until that publish flag is checked, the build results aren't synced out onto the actual download servers. So I've got a lot of control when that becomes visible. And we'll get rid of that Fedora 12 repository because none of my stuff is going to build against that, and we want to save a few CPU cycles if we can. As well as that, you've got a search interface. You can look for other people's software. You can browse other people's projects. You can look at their projects and start your project basing off them, as I described. That's pretty fully featured, but if you really want to get work done, the tool of choice is OSC, openSUSE Commander. It's a Python-based command line tool. The semantics are very similar to SVN. And it's also a Python module, so you can use that tool to create your own UIs via Python. There are also, I think, some mono libraries and a mono UI, which I haven't actually used myself. And OSC itself actually has a very powerful side, because you can use that for local build. So if you're working on a train, or you're working disconnected, you can say, well, I'm going to get all the dependencies for the package that I'm building, and then do the local build. When the local build works, and when you've got connectivity again, you can say, OK, check it in, and it'll go up to the server. But that's all fine if you're working, but nobody's an island. So we thought it would be nice, and what we really wanted to do with this, we wanted to make people able to contribute and be part of making the openSUSE distribution. So we added a rich collaboration interface. So what this means is that a guy who sees a bug in a piece of software, he probably isn't immediately going to have write access to the KDE project. But he can instantly branch his own project, just like a Git branch in Gitorious, make his branch of it, make his changes, test them, build them, compile them, and then he can say OSC request create, which sends a diff with a merge request back up to the parent project that he derived his from. We can then look at that diff, see if he's on crack, see if he's a hacker, see if he's a black hat. Most of the time he's a good guy, and we sync his changes back in, and he gets credit in the distribution. And this works at all levels. This works for any project. So we've got a series of chains of responsibility, so that in the past, where we had one bottleneck for distribution, which was two guys in Nuremberg who were the be-all and end-all for saying what actually got onto openSUSE, by the time they actually see a project and it's going to a package and it's going to go onto distribution, a lot of other eyes have had a chance to look at it. So I'm just going to check if I can demonstrate that. I was having a little problem getting online with the command line client earlier. I'll just let that sit. OK, we're good. So can anyone read that? Or shall I make the text a bit bigger? So say, for example, I decide that I'm going to make a branch of my own home project. I'll say, just demonstrate the syntax. I see how branch. So I give a project, a package, and a target. I'm branching the project M visualization tool. And I'll branch that to Alt. And there we see we've got a branch created. I'll check out that branch here now. Make a change, and in fact I'll just do that there. OSC's got lots of little useful little tools, like VC means edit the change log, and we're going to say some arbitrary change. Imagine that I'd added something. Look at a diff. create a merge request. Sorry, a submit request. Oh, it's OC request. What am I thinking? So I'm checking in my changes to my local branch. Submitting them. And then because I'm also the maintainer of the original branch, I can just use OC request here to list everything that concerns me. And there you see the request that I've just created. And if I now look in the web front end, I'm doing this all the time because I'm being responsible for a lot of changes from for community users for KDE projects. There we can see there's the request. I can examine it, look at the diff. There's the diff. Okay, nothing dangerous in there except the request. So it's a very powerful way to delegate responsibility to individual contributors. But we thought, well, it's all great to have this for openSUSE, but it's actually a lot more powerful if you take your software and make it as available as widely as possible. So we uploaded, as I said, a bunch of RPMs from other distributions. We adapted the build script so that they understood the individual distributions' differences. And it's now possible to build software from one set of sources with one control file for RPM and one control file for Debian. Obviously, they're not really compatible. And the build service will do what it does for any distribution that's going there. All the distro packages are up there, as I said. Dependency expansion is handled. So if you say it depends on KDE libs devel, it knows which other dependencies to install to create a build system. And it's got substitution rules there. So you can write one spec file, and it might be called KDE libs devel on one distribution, it might be called libkde4 devel on another distribution. It knows how to substitute those so that when you build for Mandriva, you're getting the right RPMs there. We've got a lot of macros as well. So common tasks like, for example, installing a library and running ldconfig, you get that after the package is installed. So you don't need to know the path to those commands on every distribution. You can just use one of these general macros, which will do that for you. But that's still, I mean, who here has done packaging? Who likes doing packaging? Yeah, I say that because they pay me for it. Who's got a third-party KDE application that they've worked on, that they've distributed outside KDE main modules as a tarball? Yeah. So you know what that's like. You know, you're dependent on people from every distribution to take your software, to build it correctly, to not introduce malware, and then update it. And you do a big release, and then you hope that your packaging people are going to do that for you on time. This means you can get rid of all that hassle. You can get them all doing it with you in here, but it's all going to happen for you. But it's still boring. It's still learning how to write spec files and the obscure macro language of RPM and Debian control files. I mean, I don't know anything about Debian control files. I've been using SUSE for like 10 years. But I still want to do this. So we thought we could make this a bit easier. So let me present KDE OBS Generator. This is a prototype that we've developed in the last few weeks for this event. And KDE OBS Generator is a helper tool, which you can give it a tarball. It will scan that tarball. It will see what kind of software it is. Is it an application? Is it a plasmoid? Is it just a loadable module that plasmoid loads with some metadata and some images? Is it a wallpaper? And it will create all of that build infrastructure for you automatically. All you have to do is you give it a little info file which tells it who you are and things it can't work out itself. So I'll demonstrate that for you now. So this is KVKBD. It's a visual keyboard. And if I run KDE OBS generator now, it's actually everything. All the files are there. I'm just going to remove those now. So rm Debian, yeah. So now I've got a tarball in there. Ignore that info file. I'm going to use that later. And I say KDE OBS generator. It complains that it can't find these things. So what we do is we make an info file. So excuse me. This info file is a very simple key value format. These are things that it couldn't figure out from looking at the tarball. So if there was the standard capital letter authors file in the tarball, it would have taken the packager off there. Sorry, no, that's not. That's a light. It's already taken the author out of there. But packager, it needs to know that, can't know that. URL, can't know that. License, if there's a copying.lib or a license file in the tarball, it'll use that. But in this case, there isn't one. And summary and description, that's your usual package metadata. If we do those, and we run, and we look, this is what we've got. We've got an info file and the tarball. And we run KDE obs generator. We now have all those control files. So if we look at Debian.control, and like I say, I know absolutely nothing about that, but there's somebody Debian packager here. Does that look sane? Yeah. If we look at the rules file, you can see it's using your standard package KDE tools macro to actually do the build, which is, I believe, is correct. If it's not, we want to know about it. Who knows spec files? Oh, no spec file gurus here today. Well, there's a fairly kosher spec file. It's got your prep, your build, your install. Everything, as you see, is done by macros. These macros are expanded on different distributions to the correct locations for that distribution. So it might be on user/KDE4 on one distribution. It might all be under user on another one. It might be under opt KDE4 on another distribution. All that's done for you. And if we look at the repositories that are here, we've got a list of all these repositories. Each repository is for a different distribution or different architecture, and those are all set up for you by the tool. And if we go and look at that, at the results of that in the build service now, back to this. KVKBD. You can see it's built on Fedora 10, Fedora 11, Fedora 12, Fedora, openSUSE with newer packages, Mandriva, SUSE Linux Enterprise. Of course, you're going to be voiding your support agreement by adding non-official Novell packages, but you can extend SUSE Linux Enterprise using the build service. Vanilla openSUSEs, openSUSE Factory, all the Ubuntus. It's failed on 9.10. Cannot find xtest. Oh. Well, we'll have to come back to that one. But if we just go and look at the Christmas tree just to see what this can do and how much it does get right, we're with that. Yeah, lots of green lights. That makes me happy. So this will take someone who is really not a packager and just an app developer and do 90% of the work for them in packaging their software. At the moment, it's just a a command line script. We're hoping to make it a GUI, so it's even friendlier. And yeah, we look forward to you trying it out and seeing it. So,
specific to KDE, or is it more generic?
This one is specific to KDE. This one has some heuristics in it which are KDE specific. We do have a general purpose spec file generator in progress. This is more of a quick hack to benefit mine and Lubosh's constituents, the KDE crowd.
Yeah.
But yeah.
Pure Qt applications.
Yeah, it'll do pure Qt as well. If you see there's WMIFace and Wally, those are both pure Qt applications. Yeah, so that's pretty much all I've come to talk to you about. Where are we going in future? We are improving. The web front end is a kind of Java Web 2.0 thing at the moment, but it's a little bit limiting. As part of the boosters team, we're extending that for the next release, which is in February. We want to have things like integration with other people's test suites, because there is a proprietary Novell thing that we use in-house for running tests. We'd like to integrate with that. We'd maybe like to integrate with C-Dash and C-Test. There is scope for adding all kinds of testing to the build scripts. So for example, we have a lot of scripts there which run automated tests on the results of a build to make sure it's sane, to make sure the icons are packaged, to make sure they've got sufficient metadata in the desktop files so that your apps are going to appear in the menu in the right place. All that can be extended or it can be disabled.
Does it run any of the test suites yet?
It doesn't, it could do. We could build, for example, the KDE libs test suites. We don't, because it takes a long time. But there's no reason why you couldn't do it. And I'm sure people are using it. It's just not something I personally do. The clients are available not just for openSUSE. The client is packaged for all the distributions that we build for. It's just a Python app, so you're not getting into anything by using it.
Somebody just mentioned on IRC that it's the source for this is available on Gitorious.
The source is all in Gitorious, yep.
Like just the web GUI.
The web GUI, the actual backend. There are several. It's not just one massive monolithic server. There's lots of processes. They're all in Gitorious.
So you can set up your own.
Yeah, lots of people actually are doing that. People, driver vendors, the manufacturers who give us closed source drivers for openSUSE releases, they run their own instances of this.
How easy is it to add your own distros?
It's not trivial, but it's not stupidly difficult.
Is there some kind of guide?
Yeah, it's all, like I say, it's all very, very federated, so the scope of places we have to make changes is quite well defined. Casey?
Arch support is planning?
Hasn't been talked about, but no one's actually done it yet. We've talked about Windows and Mac support.
Yeah, that would be cool.
The problem with Windows support is you have to have licenses. I think the license, actually, the Windows license prohibits you running Windows in a VM. The way the build service works internally, everything is run in a Zen VM and QEMU for platforms which don't support Zen, like ARM. So,
what about cross-compiling?
Cross-compiling is supported. At the moment, it's only working for the MER project. You know, the MER, the MIMO freeware project? They use the build service for all of their MIMO backport stuff. And that cross-compiles for ARM on x86 VMs.
Okay, so Windows, theoretically, we could do.
Yeah, if you had a good enough cross-compiler, that's one thing that we've looked at. Due to lack of resources, we haven't worked on it yet. But just to finish what I was saying about the VMs, to make sure that, because I build, your build scripts have complete control over the machine. All the build scripts are running as root. Every build is run in a clean VM instance. So a VM is created, it's installed with a minimal set of OS RPMs, the build is carried out, the built packages are synced out elsewhere, and then the VM is installed. So every time you're getting reproducibility. And
so when you build a big package like the whole of KDE, I guess you build KDE libs first.
the dependency solver schedules everything so that things are built in the correct order.
You get a VM each time for each package?
Yep, VM for each time for each package.
How long does it take once you click build? Do these things get queued up and it takes an hour or so?
It can. It's variable. I mean, I won't lie. We don't have unlimited resources. We do have several 48 gig machines with lots of cores, but they do get backed up, especially at busy times. And we do have a kind of quality of service in place, so that when we're building openSUSE in a release period, those packages are going to get preference on, my private screensaver stuff. But
or do you just kind of share it out equally between other people and have some kind of IAM services?
yeah, it's class-based, but we don't have quotaing yet. Quota is planned for, I think, the summer release 1.8. So what do we got there? We've got lots of virtual build hosts. All of these builds. These are all different machines which are working on different things at the same time.
Different physical machines?
No, these are VM instances. These are VMs running on
Each like column or each little row?
Yeah. Each row is a VM. So those are individual. I think there's actually 2 layers of VMs. But like I say, the PPC machines are all idle because nobody's submitting PPC packages. There's some volume. So let's see, there were 1,600 things waiting to build at 4:30 yesterday. These are all. There's the blocked list. If I just scroll that across there, you can see that because everything is built in the correct order, you can't parallelize it. So these are the things that are waiting something else to happen. There we go. We had roughly 200 workers. That's pretty good. We had one of our major hardware sponsors shipped us some rather alpha hardware, and a lot of it failed all at the same time at Christmas, which is quite interesting. But yeah. So that's on the PPC side. We've got 40 PPC workers.
How many kind of cores do you get in the virtual machine? Is it just like a make J1 or?
We don't. You could do a parallel build. Generally, we don't. We find that overall it scales better to build each package the slow way. You can set your builds up to build in parallel. Also, with the local build, OSC local build, you can also use Ice Cream, or you can use CC Cache, or you can use just your brute force parallelism. So that's the power architecture, not so much happening there. ARM also not so much happening there. Well, there's 180 ARM threads there if we needed it. Yeah, so lots going on. Not too much of a queue though. And OpenOffice, GCC, causes a lot of backlog. Okay, any more questions?
Is there going to be talk about hooking that into something like KDE apps?
Oh, how did I forget? Where's Frank? He's not here. He would have reminded me. And I have added that to... Yeah, sorry, I got ahead of myself there. We are hooked into KDE apps. If you go to your KDE apps project page, you can say, give it that colon-separated project path, and it will automatically sync out every half an hour your builds for all the different distributions.
That's awesome.
Yeah, because it's great for openSUSE users having this download.opensuse.org, but it's really not very findable for users of other distributions. They're maybe not conditioned yet to coming to software.opensuse.org and searching for things. So KDE apps and KDE Look are the obvious place for them to look for their KDE stuff. And we also have a notification system I didn't mention yet called Hermes, which has email and Java-based notifications of when things change. And it's also highly configurable, so you can subscribe to change notifications from particular things. And because it's XMPP and email, and RSS as well, you can mash that up and create views. So one thing that I'd love to do, which I've never gotten around to doing, maybe I'll do it this week, is write some plasmoids so you can... Your real download junkie can always be looking at a repository that he's interested in and saying, are my latest packages built yet? All right. Well, thank you for listening. Ask me if you have any more questions after the talk. That's your first port of call there. The information first page. The second link is the openSUSE instance itself. The first link, if you want to download it, shows you where you can get it from. the command line interface OSC tutorial, and then the generator tool is the last URL there.